Okay, let's go through this here. Create an equation and sketch a graph for a function with the following characteristics, okay? So we want something that's a smooth curve, it's continuous, has a minimum, and is quadratic. All right, so the keyword I saw was quadratic. Quadratic should mean x squared. It's a minimum, so quadratic is x squared, that is U-shaped, okay? Looking like this. It has to be a minimum, so I want to create a quadratic that's like that. Also, it's continuous, so I want to put together something that is x squared and a minimum, okay, and it's continuous. So again, looking back at your notes of what we've done, just kind of play around with it. Use your graphing calculator, punch in something that's going to meet that requirement. So as I switch over to things, okay, go up to y equals, and kind of play around with what we've been doing already. We've seen some examples of that. So if I just type in, say, an x squared plus 3, do I meet those requirements? Whoops, I did not do that correctly. So what I mean by that is x squared, I forgot to move out of the exponent, plus 3. I hit graph. There's my U-shaped graph. It is a minimum. That looks good to go. So now, what I want to do then is put that together. Okay, so it looked like, because the size of this graph, I was at 3, there's a minimum, it is U-shaped, it is continuous. So the equation that is associated with that is x squared plus 3. Okay, number 2, create something that is a linear. So linears are lines, okay? Sorry, I shouldn't say is a line, increasing, decreasing, or constant. It's got to be discrete, so it's going to look something like one of these 3 options. And it's decreasing across the entire domain. So because I want it to be decreasing, then I want to create something that looks like this, where it's discrete and decreasing. So as we've been doing here, let your calculator maybe give you an answer, but I know we've mentioned this a few times. A linear equation looks like y equals mx plus b. Now, in order to get to decrease, this is going back to your slope. The number in front of the x needs to be negative. Now, whatever you put in there, I don't care. But I'm going to say negative 2x plus, I'm going to make it 4, okay? Negative 2x plus 4. So when I go to graph that to confirm, I get myself a line that is decreasing. Let's go see. Get practice of using this. Negative 2x plus 4. Now remember, your graphs, your graphing calculators will give you a continuous. So when we go about to sketch this, this is good. It's a line. It's decreasing. All that looks good. What we need to now do then is just make sure it is discrete when I put it on my answer key. So 2x plus 4. Let's jot it down there. Okay. So I just want to make sure I do not connect it accidentally. And I would continue on like this. Technically it does. It gives me a nice line, and so on. Okay. Number 3. As I read through number 3, keyword is exponential. Exponentials has x as the exponent. Exponentials are my curves, okay? A whole bunch of different curves you can be doing for an exponential. So we want it to be what? Increasing across the entire domain. So this is an increasing exponential. This is an example we've been seeing, and that it is continuous. So what I want from you guys then is create something that's going to look like that, okay? That's going to look like increasing. So in this problem, we've seen a whole bunch of them. Let's just again try it and check in our calculator. Let me try, a negative 3. It's got to be to the x power because that's an exponential. So when I go check that on my calculator, I wrote, clear that out, I wrote negative 3 to the x. Is it increasing? Nope, it's not. So my guess was wrong. So let's go modify that. Maybe I take off the negative. What does that do? There we go. There is an increasing exponential curve. So I change it to y equals positive 3 to the x. So then it's continuous, and I'm just looking for a sketch of it, you guys. It's a nice smooth curve across the entire domain. It's increasing, all check, check, check. Last one is the linear absolute value. We want our V-shaped graph, okay? We want it to be a maximum. So we want it to look like this, okay? Absolute values and the quadratic ones are pretty much the same thing, okay? One's just U-shaped, one's gonna be V-shaped. So in order to get it to have a maximum, I'm just jotting down something, okay? It can be fancy as you want it, but let's try this one out, okay? Absolute value, x plus 1. Now, I know in class we've talked about what does a negative do out in front. First off, absolute value. Math, go over to num, absolute value. And I wrote down x plus 1. Now I'm going to check my guess. But I did not put a negative out front there. And right now I have a minimum. So I actually need to go back and modify. I want to make that a negative out front. That's going to open it. Oops, I want to make a negative out front. That's going to make it open down. And I said x plus 1. That's going to make it open down, and that gives me a maximum. So that's what I want. Those negatives out front makes both an absolute value and a quadratic give you maximums by opening down. So I was at like something right here. It needs to be continuous, doesn't need to be fancy, just a sketch of it. But this is where my maximum is, okay? While we're here talking, this has a vertical axis of symmetry. It's nice to just keep talking about that. And so did the quadratic. All right, the other two did not. I'm gonna pause it.